Hello, this is Tony from GreatIdeaz, and in this video we're going to explore how to add custom TSQL to the underlying database in trellispark. This capability enables you to execute any underlying operations within the database directly from the user experience. So let's have a look at what we might mean by that. So if I go to my test code generation and I go to an object, I have a drop-down list here of commands that I can execute. In this particular case, there is an example TSQL command, and if I click on this command, you can see it's gone back to the database, it's saved this record, it's executed the command, and then it's refreshed the record. So essentially what this has enabled me to do is to make a change using my currently displayed instance directly in the database. So I am able to apply changes to the SQL server using this method. So let's see how we can actually set that up. So if I go to my test code generation functionality and I go to my concept, so this is the concept that you've just seen me open up a record for, and what I have on my workflow is I've added a command here called example TSQL command, and to set this up I've given it the name of the command that I want to appear in this drop down box here, and I've given it the name of the command TSQL that I want to execute. As you can see, there's a whole bunch of other things that we can do with commands, and this is an ever-expanding list of capabilities, and we'll cover most of these options in other videos. But for this particular video, what we're interested in looking at is how do I execute a TSQL stored procedure against a currently displayed instance. And it's really simple. Okay, we say that we want to execute a command on our no lookup concepts, and this is the stored procedure that we want to execute. And if I go and have a look at my database now, you can see this is the format of that TSQL that we're going to create. So essentially, any TSQL that we want to execute directly from the user experience would have this general format. We will be passing a standard set of parameters in. So we have to pass a session GUID, user GUID, current instance GUID, and target instance GUID. At present, we are using the first three values directly from the user experience. So as always, the user GUID is the specific user identity assigned to this user when they joined a workspace. The session GUID is assigned each time a user signs in and enters the workspace. The current instance GUID is the instance that's currently being displayed. And the target instance GUID is there for future functionality that we've already decided to add around wizard interfaces and other functionality that we will be adding into the future. But for now, the three things that you need to be aware of are the session GUID, the user GUID, and the current instance GUID. So any TSQL that you want to execute back in the TSQL server, you want this general format here. Now, one thing we recommend when you write custom TSQL is that you should always validate the user session. So to make sure that nobody's calling your TSQL that's not allowed to, we recommend defense in depth all the time. So every single TSQL stored procedure, we recommend that you validate the session GUID and user GUID to make sure that the person executing the stored procedure is a valid user within the workspace and has gone through the authentication mechanism and created a valid session within that workspace. The other thing that we recommend that you do is validate that the user has read access to the instance that they're about to operate on. Okay, so not strictly speaking, absolutely necessary in all cases. This stored procedure should only be called by the user experience, and the user must already have actually validated that they have access to the object to have it on display. But there's always the clever person that's smarter than we are and has found a way to hack the system. So always a good idea. Validate that the user exists in the workspace, validate that they've gone through authentication and that they have a valid session, then validate that they actually have access to the instance that we're going to operate on. Once you've done all of that, then this is where you're going to add your custom code. Okay, so whatever functionality you want within the stored procedure, basically you're going to put here. Now, the current instance GUID is the instance GUID of the record that's currently being displayed in your user experience. As we've already said, we have already added a target instance GUID to support future updates. So one of the things that will be coming out in the future releases will be the ability to execute a wizard against an object. So essentially the target instance GUID will essentially be the data contained within the wizard operating against the current instance being displayed. So this is for future releases. At the moment, this target instance GUID is essentially going to be a null GUID. Okay, so this is giving us space for future capability releases. Now, once you've created a stored procedure and tested it, one of the things that we recommend you do is that you copy that stored procedure and add it into your functionality data model. So here, go to your functionality, go to the TSQL page and add your stored procedure here. Okay, so you want to make sure that the name is a correct match with no spaces. In this case, I'm adding a stored procedure. And what this does is that when we're moving our stored procedure now between environments, so if I take a data model from my dev environment and move it to my QA environment or move it to my production environment, then I'm also now going to copy the stored procedure between those environments as well. Okay, so one thing to think about when you're creating these functions is to make sure that you add your custom stored procedures to the TSQL tab on the functionality so that it is migrated as part of future releases. Now, one thing that also occurs when we do this is that if I go now to my test code generation and I tell it to execute SQL generation, you'll see down here, if I open this up and open this file, that my example stored procedure has now been added to the generated SQL script. And then this way I can migrate that stored procedure across environments as I re-execute the code generation script across environments. So this is a really useful way of making sure that all of the functionality relating to your database is maintained in a single place that is copied across environments in a simple, consistent fashion. So let's go back and just quickly see this happening again. So if I now go back to my test code generation, I can create a new instance of my lookup record. So here I'm going to add a new record and I can now execute my TSQL command. Now, the general execution sequence here is always the same. The first thing that happens is any changes that I've made here are going to be saved before the command is executed. So here the changes are saved. I'm going into TSQL to execute the command, and then finally I refresh the page afterwards. This means that if my TSQL command is going to make changes to my record, that I will immediately see the results of those changes on the record after the command finishes execution. When we're designing and building our user experience, these commands are not always going to be visible. One thing that we want to be able to do is restrict the visibility of commands so that they only show up in certain states of the instance or are visible to certain users who have particular roles. So one thing I can do with this command is I can restrict visibility to say, well, this command is only going to be visible in the active state, and it's only going to be visible to users who have role 1 or role 2. So I can restrict the visibility either by state or user role, and I also have the ability to declare another custom stored procedure where I pass the session GUID, the user GUID, the instance GUID that returns a Y or N single varchar, and I can use that to also restrict using a custom stored procedure whether a particular command is visible. So in this particular case, I'm going to say, well, this command is only visible in the active state. So if I make that change here, and I clear the application state, and then I go back to my test row, you can see I now have my example command and it's visible because it's in the active state, but I've also added an event called deactivate, which allows me to change the state from active to inactive. And if I look here now, you'll see that I don't have my trigger to deactivate because it's already inactive, but I've also lost my command. I can't actually do anything with this command anymore. If I go back to my other record, you'll see this is still in the active state, and I have an event that allows me to deactivate this record, and also my TSQL command that enables me to execute the operation on this record because it is still in the active state. One thing worth a quick look is, let's have a look at the definition of the workflow here. So the thing that's doing the state transitions is I've said that this particular type of record can exist in an active and an inactive state, and the default for new records of this type is active. I have created an event called deactivate, and then I've created a state transition that allows me to move from the active state. I can select the deactive event, and that's going to move me to an inactive state. And again, here is another place where I could add a stored procedure. So essentially what this stored procedure is doing is, this is before the state change occurs, this stored procedure will execute to do whatever action I need to happen before I execute the state change. If that stored procedure fails, then the state change will also fail. So I can use this essentially as a gateway to say that I have a record in the active state, I'm about to deactivate it, maybe I'll go and do some tests to see whether or not, for example, if this was an order, whether it had been filled, in which case I can't deactivate it anymore. So essentially this again is a place where I could put the same sort of stored procedures as we've been looking at so far in this video to actually do some work to figure out whether or not the state transition is possible. As well as having a stored procedure execute before I make the state transition, I can also have a stored procedure to execute custom code after the state transition has occurred. So this would be another place where I could use a custom TSQL to enable me to execute custom code directly inside the database. So there we have a simple mechanism for adding custom TSQL directly into your database to operate on your instance information. You can add it either as part of a restricted command, so that the command basically says, I can operate when this record is in this state, or when it's being seen by people with these roles, or any custom set of commands to say, well, okay, I can see it for projects under $10,000. I can see it for orders, of this particular sort of equipment. So I could use this custom stored procedure here to indicate whether this user looking at this record right now is allowed to execute this command. And I can also add TSQL to my state transitions, either before the state is changed here or after the state has been changed here. And I can also use a stored procedure here as a gateway to indicate whether or not the deactivate event is even visible to this user in this particular state. As you can see, we also have the ability to call API targets before and after, and we'll be dealing with those when we're talking about how to set up REST APIs. And in future iterations of the product, we're also going to be adding other capabilities, for example, using event hubs or Azure functions as targets for these operations as well. So, we're going to be extending the features and capabilities of both commands and state transitions in future releases. So the ability to add custom SQL into the backend database gives you tremendous flexibility and capability within the database layer itself to execute any custom code that you need and to integrate it seamlessly into the user experience, so that depending on who the user is, what record they're interacting with, what the state of that record is, what the roles of that user are, and any other custom requirements around visibility of operations, it gives you the capability of doing that quickly and seamlessly, and allowing you to make a point change into the application to add a button that enables you to just click and execute the function. And we're going to have a look at how do I get data out of the SQL Server database using TSQL when I'm looking at a particular object. So there's a couple of places where we might want to do this, and I'm just going to go through a few of the examples here in this video. So let's start with a simple example where we're trying to decide whether or not we're going to allow a concept to display a simple command. So we have our test generation functionality. There's a concept on here called no lookup, and there's a command called execute TSQL command. If this command is available, it will call this command TSQL function. And what we want to do is we want to determine whether or not this TSQL command is visible or not visible. So what I've done is I have set this command up so that the visibility is determined by this visible stored procedure. And what we need to do is we need to pass in a session GUID, a user GUID, a current instance GUID, a target instance GUID, and we're going to get a result back out of it. The result will be a varchar max output, and we're expecting either a Y or an N. So if we have a look at the implementation of this stored proc, we can see here are the standard parameters. So a session GUID, user GUID, current instance, target instance, and result. So these will be the standard 5 parameters for any stored procedure call where we want to go to the database and say, can this user interrogate this data and return some textual result? Now, in general, we're going to want to make sure that we validate the user session. So we want to validate that the user GUID is a real user in this workspace and that they have signed in and have a valid session GUID. So the session GUID user GUIDs must match. We're typically also going to want to validate that the user has read access to the current instance GUID. And then we're going to do whatever processing we need to return the result that we want. So let's start off by saying that we are going to want to show this stored procedure. So I'm going to execute this function now. So the result that's coming back will be a yes. So if I go back to my code here and I go to my test function, we will see. So if I go and have a look now, I can see that my example TSQL command is available, which is what we're expecting. So now let's go back to the stored procedure and change it. So now I'm going to set it to a no. And if I go back to my record and refresh it, we can see that the command is no longer available. So one thing that you might have noticed is I also have the result of my TSQL function being shown here. So here my example TSQL is returning a no, and the command is not available. Here, if I change it to yes, execute it again, refresh this, you can see that my example TSQL being returned is a Y, and my example TSQL command is now available. Okay, so this is cool. And this also shows another use of where we're using the get value to return data into a field. So in this particular case, what we're doing is we are using the read-only field. So if I go here, you can see I have a read-only field. So this is another example of being able to pull information out of the TSQL database as a read-only text string. So I'm going to change this around. I'm going to instead change this to TSQL hello. So I'm going to save this change and then clear the application state. Now if I just go back here and open this up, you see it's going to say fail to get the data, right? I mean, I'm trying to call the stored prop that doesn't exist yet. So let's go here, and what we'll do is we will change this to hello. We will change this to hello Tony. Execute this code. I go back here now and refresh this. You see it says hello Tony. Okay, so what this is enabling us to do is we are able to extract any data out of the SQL database as a read-only string. We can do it based on the user GUID, who is currently signed in, and the session GUID, whether they have read access to the current instance that's being displayed. So the current instance being displayed at the moment is my Rob instance here. So what we're going to say here, it can return any string, including, for example, formatted HTML. So I can change my result to include HTML tags in here. And then when I look at that value back in my user experience, you can see that my formatting is coming across here as well. So what this is basically telling us is that at any point in the database, as part of the user experience, I can extract any information out of the database I need as a read-only field. You can't edit this data, you can only display it in the database. That read-only data can be formatted with HTML. And in certain special cases where we are looking to validate whether, for example, a command can be displayed, or whether we want to put a gate TSQL on an event, if we return a Y or an N value, so capital Y, capital N, we can use it to suppress user experience elements. So this gives us a very flexible way, again, of interacting with the database to be able to pull out any text string in context.
To learn more about GreatIdeaz products and solutions, visit GreatIdeaz.com. That's GreatIdeaz with a Z.com. Thanks.